Okay, here's our experiment on Bridges 2. Okay, the first experiment dealt with a beam and we looked at how much it sagged with the application of weight. In this one, we're looking at how much supporting force is needed in order to support a weight which we keep fixed. So if you imagine there is our pivot on this side, and we have our weight of 4 newtons being created by 400 grams. And at this end we have our supporting force. Okay, now what are we going to do? Well, we need to look at how moving this supporting force towards the weight and beyond changes the size of the supporting force. So what we're going to change, the independent variable is going to be the distance from the pivot, and our dependent variable is going to be the supporting force. Okay, what we do to start with is, in setting it up, is we need to have some values, some control values. This is definitely controlled to 4 newtons, and also we're placing it at 0.4 meters away from the pivot, fixed in. In actual fact, this is held at position 10 on the meter ruler, so therefore the weight will have to go at 50 on the ruler. And in the first instance, we're going to have the supporting force at 40 as well, meaning this must be at 90. What we're getting here is, oh, we've got the 40 centimetres there already, and another 40 centimetres here. Good. Now, as I move this across, we're measuring it from the pivot, so that's the distance. Excellent. Okay, let's draw a table of results, bearing in mind the independent and the dependent variable. So, my independent variable first was the distance, measured in meters. My dependent was the supporting force. I measure in newtons, and I want to do it once, twice, and take an average of it. So there is my table of results. Good, let's try 1 or 2 values here. First of all, when I set this up, I want to make sure this is horizontal, and I want to make sure that when I've adjusted it, we have the Newton meter on 0 with the weight of the ruler. Because I'm not measuring the weight of the ruler, I'm just measuring the weight of that mass at different positions, so therefore I want this at 0. Just turn the top and to adjust it to 0. I also want on this side here, I want this fixed in firmly, but I want this loose, so it can turn quite happily in that joint. Okay, let's apply the weight. Keep this position fixed throughout the entire experiment. And what do I have here? About 1.9. So a distance of 40 and 40, 0.8, have 1.9 newtons. Okay, now let me move it until I get to 80. Make sure it's adjusted horizontally. And then let's read that off. So 0.7 is going to be 2.3 newtons. And I keep repeating this and repeating it, dropping every 10 centimetres until I get to 0.2. You might wonder how that happens, because though it makes sense up to, so we'd have 70, 60, 50, how do I get to 40? Well, I just move that onto the other side, and I keep moving it down. So there's 40. Bear in mind, of course, I need to keep that horizontal. This is much more initial on this side. And then I keep going 30, 20. Now, there's a last thing a last column I'd like you to include, and that is 1 over the distance. And that's in 1 over metres. And the way to calculate this is you take the value for the distance and you just put 1 over the distance. 1.3 if my calculator's correct. You don't need to write that bit in, you just need to write that bit in. Do the rest in the calculator. 1 over 0.7 gives you 1.4, and so on. And what that should leave you with, a series of results that I did earlier. Distance, supporting forces, averages, and then the 1 over the distance. And all of those are in the link below the video. Good, and the rest of the analysis I'll do in another video.